Hello everyone. This is Group 8, Division K, and we will be presenting on the topic Direct Memory Access. In this presentation, we'll be looking at what does Direct Memory Access mean, DMA controller, function, its modes, advantages and disadvantages, and conclusion. So DMA stands for Direct Memory Access. It allows the device to transfer the data directly to and from memory without any interference of the CPU. It enables the device to perform the task without disturbing the main processor, thus improving the performance. During this DMA transfer, the DMA controller will have full control of the system buses. Hardware systems such as disk drive controllers, graphic cards, network cards, and sound cards use this DMA technology.
Now let's look at DMAC, also known as DMA controller. It is a special kind of hardware device which controls the data transfer between memory and input-output devices with minimal intervention from the processor. It even generates and controls signals for the memory. This is the structure of a DMAC controller. It contains an address unit for generating addresses and selecting input-output devices for transfer. It has a control unit for DMA request, DMA acknowledgement, interrupt, and read and write instructions. It also contains a data count unit for keeping counts of the number of data blocks that has to be transferred.
I'm here to talk about DMA functions, which also stands for Direct Memory Access. DMA controller provides an interface between the bus and the input output devices. The processor initiates the DMA controller by sending the starting address, number of words in the data block, and direction of transfer of data. Although it transfers data without intervention of processor, it is controlled by the processor. More than one external device can be connected to the DMA controller. Now let us talk about the working of DMA. Following is a sequence of operations performed by a DMA. Initially, when a device has to send data between the device and the memory, the device has to send DMA requests DRQ to DMA controller. The DMA controller sends hold request HRQ to the CPU and waits for CPU to assert the HLDA, hold acknowledge. Then the microprocessor tri-states all the data bus, address bus and control bus. The CPU leaves the control bus and acknowledges the hold request through HLDA signal. Now the CPU is in hold state and the DMA controller has to manage the operations over buses between the CPU, memory and input-output devices.
So let us see about the DMA modes. There are three types of DMA modes: burst mode, cycle stealing mode, and transparent mode. The first one is burst mode. In the burst mode, burst of data is transferred before the CPU takes back the control of buses. Burst of data could either be entire data or burst of blocks. In this mode, the CPU stays inactive for the longer period of time. This mode is also known as block transfer mode. The second one is cycle steering mode. CPU gives the control of the buses to DMAC for one cycle in which the prepared data is transferred to the memory. The CPU processes an instruction and then the DMA transfers one data value, and thus the cycle continues till entire data is transferred by the controller. The third one is transparent mode. The control of the buses is given to DMAC only when the CPU does not require the system bus. Thus, the CPU will not be blocked due to DMAC. Maximum time is required for the data transfer as compared to burst and cycle steering mode. It is also known as hidden DMA data transfer mode. There are two formulas used to calculate the percentage of time CPU remains blocked during the DMA process. Let the time taken for the preparation of data be Tx and the time taken for the data transfer be Ty. In the burst mode, the percentage of the time CPU remained in block state is Ty into 100 by Tx plus Ty, and in the cycle stealing mode it is Ty into 100 by Tx.
So let's look at the advantages and disadvantages of direct memory access controller. So first we will see the advantages of it. So the direct memory access can save the time and it is efficient way to move a data from a memory to other devices. Next, it speed up the memory operation by not having the CPU involved. The work of CPU significantly decreases. For each transfer, only a few clock cycles are required. So let's now see the disadvantages of it. Cache coherence problem will be seen if the direct memory access is used for a data transfer. The price of system will increase with the addition of direct memory access controller. Next, the direct memory access transfer as low as than the CPU based transfer because the direct memory access controller needs to be access memory in a specific way. It can difficult be to debug the issue in the direct memory access process because the CPU is not involved. in the data transfer process. At last, we will see the conclusion of it. Direct memory access is a device that enables data transfer between input devices and memory without the CPU intervention. It allows the faster data transfer and reduces the load of CPU. Overall, we can say that the direct memory access is useful technology for improving the performance of system for data and to be transferred quickly. Thanks for watching.